Because we can store many numbers in an array, we can write many algorithms. So in the classwork from last chapter, you were asked to write an algorithm that finds the lowest value in an array and find the average of an array. So what I want to do is write this code together. Let's write code that finds the highest value in an array. So let's assume here, let's write a method, public static, and let's assume I'm given an array of floats. So we have a float array, let's call it A, and I want to find the maximum value. Because it's a float array, that means the maximum value is going to be a float. So I'm going to write that it returns a float. Now, how can I determine what the biggest number is? Imagine if you're playing a game where someone gives you a lot of numbers, like 26, 14, 84, 20, 11, 0, 9, and someone tells you, find me the highest number in this sequence. Our brains are really smart. I can look at this and immediately say 84 is the biggest number. Now, computers can't do that. Computers have to go and process one number at a time. So what I can do is I can start by saying, I'm going to assume that the maximum number is the first number, which is 26. And then I'm going to go and visit 14 and ask myself, is 14 bigger than 26? It's not. So my max remains at 26. And then I go and I check 84 and I ask myself, is 84 greater than 26? And the answer is yes. So now I can change max to be 84. And then I process the next one. Is 20 greater than 84? No. 11 greater than 84? No. 0 greater than 84? No. 9 greater than 84? No. So now I know my maximum is 84. So this is the basic idea of going through an array sequentially to find the highest or the lowest number. So what we do is we start by assuming the first number in the array is the biggest. Assume the first number is max. So I'm going to create a float variable, let's call it max equal, and I'm going to go to my array and get location 0. Now I need to visit the rest of the array. Visit the rest of the array. That means I need to visit elements in the array starting with location 1. I don't have to visit location 0 again. I'm going to go as long as I is less than a dot length until I get to the end of the array. I'm going in increments of 1. Now what is it that I want to do? I want to check if the element location I is bigger than the max I already found. I'm going to have to check. This is the element at location I. Here, a common mistake that students do is they put I here. It should be A of I. You want to go to the array and get location I in the array. Now, is that number greater than the max? Did I find something in the array greater than the maximum number I already saved? And if the answer is yes, I'm going to update my max variable. So now I'm going to say max is equal to this number that I found that is bigger. Now, how about if it's not? Then I don't have to do anything because max is already the biggest number. And after I finish all my for loop, before exiting, I can return the variable that is the maximum. So this is an algorithm that will find the maximum. Now, if you wanted to find the minimum, again, you can start by assuming the smallest one is the first element, go through the array, and this time check if you found something that is smaller, a of I less than max. Let's test it out. Let's create an array and call find max on it. So here I have a float array. 10, 50, 67, 2, 89, 16, 90, 45. And let's call find max on A3. Now find max is going to return a number. So what I'm going to do is I'm going to call system.out with that number to print it out. Number in array find max. So whatever find max returns, I'm going to print it in the system.out. And here if I look, the highest number is 90. So I should get 90 if I did everything correctly. And there it is, 90. Now, what if I wanted to add all the elements in the array, find the average? Okay, well, let's write a method that does that. Public static float find average. So with this float array, I want to find the average. Well, if we remember, average, I want to say here return average. Average is the sum divided by the length of the array. So what I need to do is I need to find the sum of the elements in the array. So just like we did before, I can create a sum equals 0. I need to go through all the elements in the array, starting with location 0 until a.length. And what I need to do is I need to add every element to sum. So I'm going to the array and adding every single element in the array to sum. And at the end, I'm going to divide by the length. Now let's try running find average on our array. And it says that the average is 46.125. Okay, so these are some algorithms that you can do using arrays. Let's see, what else can we do? Now, when we're dealing with files, we talked about files a little bit in the last video. And just to recall what we were doing, what I had here was a method called getFriendNames. I opened a file called friends.txt and started reading, and everything that I read from the file, I put it into the array. Now, because I am dealing with files here, what I did was I assumed I knew the size of the file, which was 3. Now, what if I don't know the size of the file? What can I do? So there are 2 answers to this. Okay, so let's kind of write 2 methods that we're going to use to read the contents of the array. Again, so this one I'm going to call it get names. Assume, let's just call it 1. Get friend names 1. Okay. Again, it's going to have to throw an IO exception. I'm going to still have to create my file in Scanner. So let me just copy that code. And now what I want to do is I want to create my friends array. And I don't know the size of it. So one way to do it is assume that the file will not have more than a certain number. So I can assume, for example, that if this is the number of friends I have, I'm going to assume that I don't have more than 100 friends. The number of students in a class, I'll assume I don't have more than 30 students. So what you do is you start by assuming a high number for the file content. You know, if it's temperatures, you know, the file contains temperatures from different days of the year, you know, the maximum is 365. So what we do is we assume a high number in the file, and then we do the same thing that we did before. I'm just going to copy this code to save some time. So here I'm assuming that I'm not going to have more than 100. I'm going to start out with I equals 0, and I'm going to read 1 at a time into location I. So I'm going to read into location 0, 1, 2, 3, and so on until I'm done. And then I'm going to close the file and return this friends array. Let's test it with the same file that we had that only had 3 elements. Now here, instead of 100, I'm just going to make it 10 so that it's a little bit easier on printing. So I'm going to go up to my main, and I'm going to call getFriendNames again down here. Okay, but this time I'm going to call method 1. And we don't want to create names again. So we'll just say names equal. And let's try and see what happens when we do this. So I get the first 3 names are there, but I'm getting null. Why am I getting null? because my array is partially filled. I created space in RAM big enough to store 10, but I only put 3 elements in there. What is in the rest of the array? Null. If it was a number array, it would just be 0. So how can I solve this partially filled array? Well, one thing I can do is in my printing. So when I go to print the array, I'll just say, I'll add an extra check. And this keyword null, I can say if x equal the word null. Well, actually, I want to say if it's not null. So if it's not null, then I'm going to print it. So let's try that. So now it only printed 3. So when you're dealing with files and arrays, there isn't a beautiful solution. So what I did here was I just said, I'm going to assume a big size, and I'm going to be wasting space. So, if we think of this method of doing things, what I did was I assumed the file will not contain more than 10 students. Okay. And I read in what I could and filled the array. So now I ended up with a partially filled array, an array that was not full. Okay. Now, are there disadvantages to this? Yes. One disadvantage is that I'm wasting space. Okay. I needed 3 strings and used 7. I used 10. So I wasted 7. There are 7 spaces that are not used. They're held by the RAM is held by my program, but I'm not using them. Another disadvantage. Anyone who uses the array needs to ignore the extra spaces. Needs to ignore the the null value, right? So this is one way you could fill an array from a file. Let's look at another way that we could do it. So I'm just going to copy this code again. And this time what I'm going to do, let's change the name to 2. What I'm going to do at this point, because I don't want the disadvantage of wasting space, what I'm going to do is I'm going to read the file twice. So here I'm opening the file. I'm going to read the file. So here I'm going to say read the file to determine the number of elements in it, to know how big it is. Okay, so here I'm going to say int size equal to 0. I'm reading it and it has some stuff, so I'm going to just read one line and then I'm going to say size plus plus. What is this doing? It is just counting how many lines are in the file. So it's reading a line and counting it, reading a line and counting it. So once I reach here, I know that my size, my array, my file has 3 lines or 10 lines or whatever number of lines it is. So I can use this number, use the size to create the array. So here I know the size. No more wasting space. Now, if we do this, we have to make sure that we close the file because we're going to have to open it again so we can start reading again from it. So close the file so I can reopen it for reading. Okay. And I'm going to have to recreate the file again, my scanner again. So I'm going to just come here and recreate the scanner. Recreate the scanner. And I can just say input file equal new scanner again. So here what I'm doing is I opened the file to count how many lines are in it. I am done. I close the file and now I'm going to open it again. I don't have to create the file object again because it's already pointing to friends.txt. So I'm opening the file again. I created my array with the correct size and now I'm going to be reading into the array. Okay, and I'm going to return it. Let's see what happens when I use this get friend names too. So let's come here and, oops, and call method 2. Now what I'm going to do, just to make sure that we don't have any nulls, I'm just going to comment this line out that was checking for the null. And so here I see that the array really does only have 3 elements. It doesn't have 10 like the original one. Why? Because I took the extra effort to count the contents of my array, my file. Okay. So why would we want to use this, or why wouldn't we want to use this? So let's just to recap what we did was, number 1, we opened the file and counted how many lines are in it and saved it in size. Then we closed the file and reopened it. We created an array with the correct size, and then we read from the file into the array. What are the advantages? Advantage. Okay, no wasting RAM. I only allocate RAM for my array as much as I need. If I need 3, I'm using 3. So what is the disadvantage? Wasting time. Wasting CPU time. This program is going to take longer. I had to go through the file twice. I opened the file one time to read the entire content just to see how many lines it has. And then I opened it a second time to actually read the contents and save it. So here, this is a trade-off that you as a programmer will have to sometimes make. Am I okay with wasting RAM, or I'm okay with wasting time? Which one is more important to me? And so arrays have this limitation because you have to know the content of the size of the array before you start. Okay. We talked about methods that are returning arrays in the last video. Now, 2 more things that I want to just point out. You know, when you're going through a string and you want to call the length method, you put length and then you put the empty parentheses. So remember that length is a method that is available on strings, but length that has to do with arrays, it's not a method. It is actually a field, an instance field that is stored in an array. So just make a note of length for arrays doesn't have the parentheses, but when we're dealing with strings, just finding the length of a string, you need the parentheses. I just wanted to point this out. Now, other things that you can do with arrays is you can sort and search arrays. And there is a built-in method that can do that for you, or both of them for you, and they can be found in java.util.arrays. So what I'm going to do is I'm going to show you an example of both. So the first thing I'm going to do is import java.util.arrays. So let's go up here and import it. Java.util.arrays. And this is used for sorting and searching. Now, how do I use it? Let's here use sort the arrays. Now, let me just change the contents of the array so that they're not sorted. So here I'm going to say 30, 20, or 30, 10, 20. And let's just make this 60, 50, 40, 70. And I want to sort A1 and A2. How do I do that? Well, what you do is you go to this class that we just imported, which is arrays, and we call a sort method in it. So it has a method called sort, which is a static method where you give it the array and it sorts it for you. So all I have to do is say arrays dot sort, and I give it the arrays. So if I'll sort A1, and I can sort A2, and I can even sort names. So now that I sorted those 3, let's print their contents. So let's put let's put print array A1, print array A2 and print array names. Let's see if they got sorted. So the sort is actually changing the order of the array. So it's going to be modifying the array. So my array is now 10, 20, 30 back. It used to be 30, 10, 20. So it got sorted. My second one got sorted, and my names got sorted. So you can actually sort any primitive data type. All the numbers, chars, strings. Strings are not primitive data types, but you can also sort them. Okay, so that is what I can do with sorting. Now, how about if I want to search for an item in the array? So arrays, that class again that I imported, has a method called binary search. And the way binary search works is that you give it an array and a value that you're searching for. And if it finds it, it's going to tell you where it found it. If it found it, it's going to return a number between 0, like that is 0 and greater, because those are the valid indices in the array. If it doesn't find it, it's going to return a negative number. So let's give it a try and see how it works. So I know that A1 has 10, 20, 30, for example. So let's go and say arrays. I want you to do a binary search on A1, and I want you to find 70. Now, or let's make it 100. So here, 100 is not in this array. So if I try printing what this is going to give me, I'm going to get a negative number because it's not found in the array. So it returned a negative 4. Now, if I try searching for a number that exists, which is 10, for example, I'm going to find it in that case. Okay, so it told me that it found it at location 0. There it is. Now, binary search has a requirement. The requirement is the array must be sorted. If it's not sorted, we might get the correct answer, we might not get the correct answer. So let's just try searching for 10 in the original array. So here, if I just come here and try searching for A1, I'm going to find it actually at the beginning. So if I go and search here, it says that I found it. But if I try searching for 20, let's see if it finds 20. Actually, it found 20. Let's modify it to be 40. Let's see. Let's put a 15 in there. Let's see if it finds 15. So here it didn't find 15. So the way binary search, we're going to cover that more in Java 2, but binary search basically assumes the array is sorted, and then it goes to the middle and says, did I find it there? And if not, it goes and sees where it should. It's kind of like if you're playing a guessing game. You know, if someone tells you, I have a number in my mind between 1 and 100, and I want you to guess the number. What you do is you say, okay, the number is 50. And if they say bigger, you start looking for a number between 50 and 100. If they say smaller, you start looking for a number between 0 and 50. So what binary search does, it goes to the array, and it says, okay, let's search for the number they're searching for in the middle. So if I say 15, it comes in the middle. Let's say it thinks 10 is the middle one. And it says, are you 15? And it's going to say no, or actually, I think it's going to go to the 20. Are you 15? And it's going to say no, I'm smaller. So it's going to go and search this half, and it's not going to search this half because it's not sorted. So just for now, what I want you to know about binary search is that you need to make sure the array is sorted. So this does not find 15 because the array is not sorted. So make sure that you call the sort array first. So here at the bottom it was working because we sorted the arrays first. So these are all different algorithms that you can do with arrays. So for this classwork, what I want you to do is practice working with files. So you're going to create a file that has these numbers in it, each number on a separate line. You're going to write a method called file to array that's going to create an array. It is going to ask the user for a file name, open the file, read the numbers into the array. The function should take the scanner object as input and return the array created. Why does it need to take the scanner object as input? Because in HackerRank, it only allows you to create one scanner to keyboard. So what we want is to create the scanner in main and then pass it to array method. In main, you're going to sort the array that was read from file to array, and you're going to ask the user for a number they want to search for. So as long as the user keeps entering like numbers, it's going to search and see if they're in the file or not. If the user enters -1, it's going to stop. So you're going to have to use a while loop to keep searching. Now for this code to work on HackerRank, we have to create that file. So add those 3 lines of code to the beginning of your main so it creates the file for you.